Hello everyone, and welcome to the walkthrough of our current mockup of 3DPackRAT, which stands for 3D Packing Research Application Tool. Before we get started, I'll explain briefly what 3DPackRAT is and what it does. So, 3DPackRAT is a demonstrator developed for the project 3D Printing Production Planning at Nottingham University in a collaboration between the 3D Printing Research Group and the Automated Scheduling and Planning Research Group. The project is funded through the 3DPRDM Feasibility Study competition. The goal of the demonstrator is to show that it is possible to jointly solve the problems of packing build volumes and machine scheduling in a single approach. This will allow future users to create an optimized workflow for a number of 3D printing systems, which will make industrial 3D printing more efficient and also responsive. Essentially, the idea is that orders are submitted to 3DPackRAT, which then uses a decision-making logic drawing on different heuristics to decide the best machine and time to make a part. This process is automated and produces an optimized workflow. We start the mockup by logging into the system at 3dpackrat.com. I should state at this point that what I'm showing you is our current mockup, so the idea is to give an impression of how the demonstrator will look like. Now we're in the main system interface showing a T by K view with T time periods. The current period is highlighted in green, shown here as a horizontal bar in the center of the view. The view contains K machines, in this case 3 laser sintering systems. On the left-hand side, we find a few buttons to interact with, for example, to add an order for a part or to execute the builds contained in the view. The main view provides us with an overview of what's going on with our 3D printing machines over time. It also shows some summary information about the status of individual builds. This includes information on the machine, build utilization, and whether the parts in the build will be produced on time. By clicking on a particular build, say the build on the following day on machine 1, I can enter a detailed view on the current configuration on that machine. In this view, I can obtain additional information on the build on the right-hand side and can have a look at the current build configuration in 3D. Back in the overview, what happens if the operator receives an order for a part is that she clicks on the Add Part button. After uploading the part, the combined packing and scheduling functions in 3DPackRAT will automatically choose a suitable build based on the part's geometry and target date. Once the planning for the current time period is complete, say at 4 o'clock today, the current builds will be executed. Executing the builds will prompt a download for fully packed build files ready for the 3D printing process. So, to summarize, the project is developing a demonstrator that combines build volume packing and scheduling functions in a single approach. In this video, I've shown you a mock-up of this system, aiming to automatically create an optimized workflow for industrial 3D printing. Thank you very much for watching this video. For more information, please visit us at 3dpackrat.com. Thanks again for watching.